Hello kids, welcome to Rapid Gyan. In the last video, I have explained the concept required to solve this exercise 1.1, and in this video, we will be solving this exercise. So those who have not seen that video yet, I will strongly recommend to go and watch that video first. You can get the link of that video in the description of this video below. Also, after watching that video, please make sure to solve this exercise 1.1 by yourself. Once you guys are done with your solution, then only watch this video to verify your solution. Also, this video will help you in writing the solution in your exam. Alright, so let's start with the first question of your exercise 1.1, which is this one. So I will go ahead over here. Okay, so we are going to solve this question 1. So question 1 is saying that use Euclid's division algorithm to find the HCF of these three parts are given over there. So we will start with the first part, which is find the HCF of 135 and 225. Now, so it's very important. In the previous lecture also I have mentioned that it's very important to read the questions carefully, because it's clearly mentioned that you will have to use Euclid's division algorithm. So you cannot find the HCF of these two numbers by the normal methods which you guys have studied in your previous classes. So we will have to use the Euclid's division algorithm. So what you are seeing over here in the first part, there are two numbers 135 and 225. So we can clearly see that the 225 is greater than 135. So here your 225 will become your dividend, right over here, dividend, and 135 will become your divisor. Okay, so now I'm going to divide 225 with 135. So of course it will go just by one time. So it's 135 and it's 0, 9. So your remainder is 90. So now you will have to write this in the Euclid's division algorithm type. So this will become your dividend is equal to your divisor multiplied by your quotient plus remainder. Now you can see here, since remainder is not equal to 0, since remainder is not equal to 0, so now remember what I have told, your divisor will become your new dividend and your remainder will become your new divisor. So we will do it again. So with the new dividend and new divisor, so which is your 135, I will divide this with 90. So again it will go just one time. So it's 90 and my remainder is 45. Correct? So this I can write it as 135 is equal to 90 times 1 plus remainder, which is 45. Again your remainder is not equal to 0. So we'll do this activity one more time. So while doing this one more time, so your now 90 will become your dividend and 45 will become your divisor. So here I will divide 90 by 45. So it's going 2 times. It's 90 and now my remainder is 0. So here I can write it like this, 90 is equal to 45 times 2 plus 0. Now my remainder is 0. So as I have told you in my previous lecture that if your remainder is 0, at that time the value of divisor will become your HCF. So here I can write this, that HCF of 225, 135 is 45. That's your answer. Okay, now we'll go ahead with the second question. So second question is saying that you will have to find the HCF of 196 and 38220. So first way, so which one is the greater number? 38220 is your greater number. So 38220 will become your dividend. I'll write over here 38220 will become your dividend, and I will divide this with 196. So while dividing this with 196, so it will first go by one time. So one time here it's 196, and if I will subtract this 196, so what will be my answer? So I will get 186. Okay, so now this 2 will come down, so this is 1862. So if I'm going to divide 1862 by 196, so it will go by 9 times. So right over here is 9. So what will be my answer? So 196 multiplied by 9, which is equal to 1764. 1764. So now when I subtract 1764 from 1862, so my answer is 98. So I will get over here 98. Now this 0 will come down, 980. So now 980, if I'm going to divide with 196, so it will be completely divisible when I will multiply with 5. So now it's 980, and here I got the remainder 0. So what you are seeing over here, in the first attempt itself you got the remainder 0. So it's simple, so you can write it like this: dividend 38220 is equal to your divisor, which is 196, multiplied by 195, which is your quotient, plus remainder. So now in the first step itself I got the remainder 0. So what will be my HCF? The divisor will become my HCF. So this divisor will become my HCF. So you can write over here that since remainder is 0, so HCF of 38220, 196 is 196. That's my answer. Right, so let's start with the third part of this question, which is your 867 and 255. So you can clearly see that 867 is the bigger number, so which will become your dividend, and this one will become your divisor. Divisor. Okay, so first we will do the division. So 867, when I will divide this 867 with 255, so it will go 3 times, and when we go 3 times it will come 765 over here. So my remainder will become 102. So 102 will be my new remainder. So I can write it over here that 867, which is your dividend, is equal to 255 multiplied by 3 plus 102. Now you can see that my remainder is not equal to 0. When my remainder is not equal to 0, this 225 will become your new dividend, and 102 will become your new divisor. So I will divide over here that 255 divided by 102. Okay, so clearly you can see that it will go 2 times. So I will get over here is 204, and my new remainder is 51. Correct? So next line I can write over here is that 255 is equal to 102 multiplied by 2 plus 51. So 51 is my new remainder. Again, remainder is not equal to 0. So if remainder is not equal to 0, what will happen? 102 will become your new dividend, and 51 will become your new divisor. So we'll do over here 102 divided by 51. So it will go 2 times, 102, and now my remainder is 0. So I can write over here is 102 is equal to 51 times 2 plus 0. Okay, so now my remainder is 0. So as soon as you get your remainder is equal to 0, so at that time the value of divisor will become your HCF. So my answer is of HCF of 867 comma 255 is equal to 51. So that's my answer. Alright, let's go to your next question. So next question is saying that so that any positive odd integers is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is any is some integer. Okay. So what you are seeing, looking, we can clearly see that the 6q plus 1, 6q plus 3 and 6q plus 5 are nothing but written in the form of Euclid's division lemma, Euclid's division algorithm. So and we can see that 6 is your divisor, correct. So now first let's write all the like some positive odd integers. So some of the positive odd integers are 1, 3, 5, 7, 9, 11, 13, say 15, 17 and so on. Okay, and your divisor is 6. So first I will start dividing these numbers by 6. So what I will get? So if I will divide 1 by 6, so what I will get? 1 divided by 6, so it will go 0 times and here it's 0 and my remainder is 1. Similarly, if I divide 3, so same 6, 0, 0 and here I will get remainder 3. Now I will divide 5 with 6, so again 0, 0 and my remainder is 5, correct. So if I will divide 7, so now 7 will go just one time, 6 and my remainder is 1. So in this way it will go on. So I will just try to write it over here. So what the pattern you will see, the first is 1. So in the first case your dividend is 1. So 1 is equal to 6 times 0 plus 1. Okay. Next is 3 is equal to 6 times 0 plus 3. Okay. 5 is equal to 6 times 0 plus 5. Next if I will go with 7, so 7 will be equal to 6 times 1 plus 1. 9 will be equal to 6 times 1 plus 3 and 11 will be equal to 6 times 1 plus 5. Now next set I will try, so 13 will be equal to 6 times 2 plus 1. 15 will be equal to 6 times 2 plus 3 and 17 will be equal to 6 times 2 plus 5. So what's the pattern you are seeing guys over here? So you are seeing that in all these three columns your divisor is same, your quotient is changing in all these three things, okay, and your remainder is same. So you can clearly write that, and these are nothing but the positive odd integers. These all are positive odd integers. So I can clearly say this I can write as a 6q plus 1, 6q plus 3 and 6q plus 5. So this is just to explain you guys, to make you understand the concept why we can write all the positive odd integers in the form of 6q plus 1, 6q plus 3 or 6q plus 5. But now if you will have to solve this question in your exam, so how you are going to solve that, I am going to explain that now. Okay. Since your divisor is 6, so if your divisor is 6, so what are the possible values of remainder? So remainder will always be greater than or equal to 0 and less than 6. Less than 6 means till 5. So I will just write it over here: 0, 1, 2, 3, 4 and 5. So these all are the possible remainders, correct? So simply what you will, and suppose there is any positive integer, so I will write let any positive integer equal to a. Okay, so if I will divide a by 6, I will get some q and I will get some remainder r, and here it will be 6 times q, 6q, so I will get some remainder r. Okay, so and so how I am going to write this? So this and what are my possible remainders? So possible remainders are 0, 1, 2, 3, 4 and 5. So you can write this, that what will be the possible output. So possible output will be 6q plus 0, okay, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4 and 6q plus 5. Correct? So these all are my possible outcomes. Now if you look into these numbers, what you are getting? So this 6q plus 2 and 6q plus 4. I'll write over here 6q, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4 and 6q plus 5. Okay, so you can see 6q is divisible by 2. Yes, I can write it like this, 2 times 3q. So it means it's divisible by 2. But this number 6q plus 1 is not divisible by 2. Again 6q plus 2 is divisible by 2. So it's 2 in bracket 3q plus 1. Here 6q plus 3 is not divisible by 2. For 6q plus 4, I can write 2 in bracket 3q plus 2. Correct? And again 6q plus 5 is not divisible by 2. So what by looking into this data, like this particular information, what are you analyzing? So you are clearly, we know that any number which is divisible by 2 is your even number, and the number which is not divisible by 2 are odd numbers. So here we can clearly see that 6q plus 1, 6q plus 3 and 6q plus 5, these are the three numbers which are not divisible by 2. It means they are odd integers. So I can say that odd integers, we can write odd integers in the form of 6q plus 1, 6q plus 3 and 6q plus 5. Okay, so that's your solution. Now we will go to the next question. Next question is, an army contingent of 616 members is to march behind any army band of 32 members in a parade. Okay, the two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Okay, so let's assume that the maximum number of column is x. So let's assume that the maximum number of columns equal to x. Okay, so there, how many members are there? 616 members are there. So this 616 members will be marching in x columns. So of course there will be some y number of rows, correct? And these 32 band members, so I will just write here is just, they are just members, and then for band, so there are 32 members which will be marching in x number of columns multiplied by some number z number of rows. So you remember we have solved the questions of Kaju Barfi and Badam Barfi. So this is a similar question. Okay, so here if I'm going to make the columns, okay, and rows. Okay, so these are the few columns. Okay, so these columns, and they will have some number of rows. So this x is the number of columns, and might be I will divide it from here. So there will be multiple rows, correct? So in this way they march. So in that, few rows are for the members and few rows are for the band members. So this will which I have assumed as y, and this I have assumed as z. Correct? So in this way they will be marching. So looking into this, what you are seeing, that the factorization of 616 is x times y, and the factorization of 32 is x times z. So, and in order to get the value of x, we can clearly see this is nothing but we will have to find the HCF of 616 and 32 using Euclid's division lemma. So just now we are going to find the HCF. So HCF of 616 comma 32 we will have to find. So again we will go with the division rule. So 616 I will divide it by 32. So this is 1. So if this is 1, so I will get over here is 32. So which is equal to, if I will subtract, I will get 29. Then this is 6. So it will go now 9 times. So 32 9s are 288. So it's 288. Then I will get 8. And then again, so if I will get 8 over here, so 8 is my remainder. Okay, you can see 8 is my remainder. So I can clearly write it over here that 616, which is your dividend, is equal to 32 times your quotient 19 plus 8. Now your remainder is not equal to 0. So this 32 will become your new dividend and 8 will become your new divisor. So we can clearly see that 32 is completely divisible by 8 4 times. So 8 4s are 32 and my remainder will be 0. So here I will get 32 is equal to 8 times 4 plus 0. Since my remainder is equal to 0, so at that time the divisor was 8, so this will become my HCF. So we can say that the HCF of 616 and 32 is nothing but 8. So 8 is your answer. So in the exam you can write it. The question is saying what is the maximum number of columns in which they can march. So we can say that the maximum number of columns in which they can march are 8. Okay, so let's move to your next question. So next question is, use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Okay, so we have already solved this kind of question. The only difference over here is that you will have to find the square of the positive integers. And earlier we have only solved it either is for the even integers or for the odd integers or just for the integers. So okay, so let's solve it. So first assume that that the positive integer be x. So if the positive integer is x, and you can see from this that it's 3m and 3m plus 1, it means my divisor is 3. So if divisor is 3, so possible values of remainders are 0, 1 and 2. So and if my number is x, so what will be my possible values? So it will be, I'm not talking about right now, I'm not talking about a square, I'm just talking about simple positive integer. So if it's a positive integer is x and we are dividing it by 3, so what I will get? I will get some 3m plus 0 or 3m plus 1 or 3m plus 2, correct? So, but now what we will have to do? We will have to do the square of these possible values, because we will have to find in the question it's clearly mentioned that we will have to prove for square of the positive number. So what was your positive number? Your positive number of x. So square of x will become your x square. So its possible values will become, this will become your 3m square. Okay, this one will become your 3m plus 1 square, and this will become your 3m plus 2 square. Okay, so this 3m square I can write it as 9m square. This you guys must remember the a plus b whole square formula. If not, I will just write it here. So a plus b whole square formula is saying a square plus b square plus 2ab, correct? So this will become 3m whole square. So 3m whole square is nothing but 9m square, okay, plus b square is 1. So 1 square will be 1 only, and 2ab. 2ab means 6m. Similarly, if I am going to do this, so this will become your 9m square plus 4 plus 2 3 is 6 2 is 12 m. Okay, 2ab means 2 times 3m, which is 6m, times 2, which is 12m. Okay, so now look into this, and now you will have to divide this with 3. So, and further I can clearly see this 9m square is divisible by 3, because I can write in this form 3 times 3m square, correct? This, take these two numbers together, so which I can write it as, I can take 3 common from these two expressions, and in the bracket I can write it as 3m square plus 2m plus 1, correct? And in this case I can further write this in this form, 9m square plus 12m, and this 4 I can further divide it and write it as 3 plus 1. And from first 3 expression I can take 3 common. I will take 3 common, what I will be getting 3m square plus 4m plus 1 plus 1. Okay. So look into this, what you are seeing. You are seeing that this, of course, this 3m square is any particular integer, because put any value of m, you will get some integer. Here also, just put any value of m, you will get some integer, and here also you can put any value of m and you will get some integer. So we can collectively, I can write this as a 3m, this as 3m plus 1, this also as 3m plus 1. Hence we can say that the square of any positive integer can be written either in the form of 3m or 3m plus 1. Hence put. Okay, so let's move to the next question. So which is the 5th question, and this one is the last question for this exercise. So it is saying, use Euclid's division lemma to show that the cube of any positive integers is of the form 9m, 9m plus 1 or 9m plus 8. So earlier we have solved it for, in the last question we have solved it for the square. Now we will have to do the same thing for cube. Okay. So if we will go with your last approach, so in by that approach, here what we are seeing, your divisor is 9, and if I am going to assume the value as x, so and I am taking the divisor as 9, so what will be my the possible remainders? So my possible remainders will be 0, 1, 2, 3 till 8. Okay, so in this way, if I am going to write all the possible values over here, so there will be 9 records. It's like 9 cube plus 0, 9 cube plus 1, 9 cube plus 2, 9 cube plus 3, and so on. And it's going to be very huge, because after that we will have to do the cube of that. So think before, we will have to get 9 as a divisor. So instead of taking 9 as a divisor, if I will take 3 as a divisor, if I will take 3 as a divisor, and since we will have to get the cube, so 3 cube will be 27, and in the factor of 27 I can get 9, because it's 9 times 3. So we can solve this question by taking 3 as a divisor instead of taking 9 as a divisor. Even though you can solve this question by taking 9 as a divisor, but that will be very lengthy. So we will have to save time in the exam, and also we will have to find the smartest way to solve the question. So in this question we are going to take 3 as a divisor, because anyway if we are going to make cube of 3, so my answer will become 9 as one of its factor. Okay, so if I'm going to take 3 as a divisor, so my possible remainder values will be just 0, 1 and 2, correct? So here I am going to take the possible, write the possible values. The possible values will be 3 cube plus 0, 3 cube plus 1 and 3 cube plus 2. And since question is demanding to write the cube, so x will become your x cube. Let me change the pen color. So x will become your x cube This I will write 3q cube. This I can write it as 3q plus 1 cube, and last one I can write it as 3q plus 2 cube. Okay, so 3 cube will be simply, I can write it as 27q cube. This I can write, how will write? So if you remember the formula of a plus b whole cube, so what's the formula of a plus b whole cube? It's a cube plus 3a square b plus 3ab square plus b cube. So we are going to use this formula over here. So 3q cube. So 3q cube will be 27q cube plus 3a square b, means 3 times a square. A is your 3q. So 3q square will be 9q square. So 9q square multiplied by 3, which is 27q square times b. B is 1. So here I will get 27q square plus 3ab square, means 3 times 3q is 9q plus multiplied by 1 square, which is 1. So I will get 9q over here, and the next one will be your 1 cube, which is 1. Similarly, if I'm going to do this, so this will become 27q cube plus 54q square plus 36q plus 8. Okay, so now I will have to write this in the multiple of 9, because in the question I will have to prove 9m, 9m plus 1 or 9m plus 8. So from here you can clearly see that you can write this 27q cube as 9 times 3q cube, correct? This, from the first 3 terms you can take 9 common. So if I will take 9 common, what will I get? 3q cube plus 3q square plus q, and then plus 1. And in the last again, if I can take 9 common from first 3 expression, so I will get 9 common, so I will get 3q cube plus 6q square plus 4q and plus 8. Now you can see that if I am going to put any value of q, this whole is going to give me some integer. So this I can write it as 9m. This I can write it as 9m plus 1. And the last one I can write it as 9m plus 8. Because see, if you are going to put any value of q over here, the output which you will get will be some integer. So what will be that integer? We don't care. We'll just write m. M is that integer. Here also, if you are going to put any value of q, your answer will going to give you some integer, which is again I am assuming as m. So what we are seeing over here, that we have assumed any positive integer. We have started with the any positive integer x, and by making the cube of, and we have written all the possible values of that, and after making the cube of that, we can clearly see that cube of any positive integer can be written in the form of 9m or 9m plus 1 or 9m plus 8. That's it. It's proved. So alright student, so we have covered this whole exercise 1.1 in this video. So please subscribe the channel and turn the notification on so that you will be notified as soon as the next video will be uploaded. We are going to upload the next video on the exercise 1.2. So first we will explain the concept of exercise 1.2. So the introductory video will be uploaded first, and the next video will be the solution of exercise 1.2. So if you subscribe the channel and turn your notification on, you will be notified as soon as the next video will be uploaded. Also, please like and share this video so that the other students can also be benefited who are in need. And if you guys are having any doubts, you can post your doubts in the comment section. We will answer it, or you can write us an email to info@rapidgyan.com, rapidgyan.com. Thank you.